So what we are going to do is, as part of this project, we'll first take a video URL of interest. We'll take a URL of interest. We'll use the pytube library to download that video from YouTube. So for the purposes of this tutorial, the video is going to be a YouTube video, right? So I'm going to take a YouTube URL, download it using pytube. Once we have this video available, we are going to use FFmpeg to then extract the audio. So so you first get the video. From the video we extract the audio stream. That audio stream gets saved on the disk, and we then use that audio stream to send as an input for the OpenAI Whisper model. Now again, here what we are going to do is, we are not making use of the Whisper API, which is a paid API. We are going to make use of the model that is locally going to be present for our systems, right? So we are going to be making use of the free model, the open source model. I have also done a video on OpenAI Whisper earlier, where we did very similar thing, but we did not use FFmpeg there. There we downloaded an audio file itself. So here the new addition is, the video will we will first download the video file. Then using FFmpeg, we are going to come to the audio part of it, and from there we'll get to the OpenAI Whisper, which will then give us the transcripts. We'll do some pre-processing on the transcripts, because there are some formats which we'll talk about for the subtitles. The time formats will do some pre-processing. Once that pre-processing is done, we'll again use FFmpeg to now embed the subtitles in the original video that we downloaded. There are two ways when you embed subtitles. One is the hard embedding, which is basically you're saying, hey, you are burning the subtitles on the video, so though they are always going to be there, you cannot switch them off. The other is, which you might have seen, which are more like closed captions, where you can have several languages as part of your subtitles, and you can generate a SRT file, which then the video can find and accordingly play, right? Basis what, if the user wants subtitles in English, it can be played. If the user wants subtitles in Spanish, they can be played, right? For the scope of this video, we are going to embed the subtitles. So the subtitles are going to be hard burnt on the video. So let's get started, right? So this notebook has all the steps. Now we'll get to the coding part of it. We'll use these three libraries. We'll first use Faster Whisper. We'll use FFmpeg Python, and we'll use pytube. These libraries, let's first get them installed. The way to do it is, you should go out and create an environment. If you already don't have an environment, I recommend you create an environment. I'll just create an environment. Let me just create a Python cell, run this. Why I did that was because it will automatically ask me for the Python environment. I'll say I want to choose a Python environment. I want to create a new Python environment. We'll say we want a .venv type. This is my interpreter, Python 3.12. And if you already have a requirements.txt, it will ask you to select that requirements.txt if you want those dependencies to be installed. So we'll just do this. It will now go out and create the environment. So our environment is now created. I can quickly go to the terminal, and if I see .venv, I know that my requirement is created. I can do a pip freeze, and we'll see we have all of these libraries installed. FFmpeg Python is part of it, so I know that my requirements.txt was also installed. That those dependencies were installed. So from a requirements perspective for this video, we are making use of Faster Whisper, which is basically a C translate 2 implementation of the regular Whisper model. This is again an open source model. So if you go to github.com/systran Faster Whisper, you can read through what this implementation is all about. Given that this is a C translate 2, which is again a fast inference engine for transformer models, the author claims that this is basically 4 times faster than your regular model, regular implementation which Whisper has done. And if you do quantization, it is even faster. What we are going to do is, we are just going to run it without the quantization today. So let's get started. I want to talk about why we are using Faster Whisper, and the reason is that transcriptions take some time. If there is a way which allows us to do faster transcription without losing too much on the accuracy, I think it's better to go with that approach, right? So we're going to use faster Whisper because of that. So now let's get to the first step where we need a URL, and we'll then use PyTube to download that video. For that purpose, I'm going to make use of this video. OpenAI recently came out with their GPT-4o model, and this is the video. I'm sure a lot of you must have already seen this demo video. I'm going to make use of this video and basically use this to download this video file, right? So we'll need the URL. So I'm just going to copy this URL, and this URL is our URL of interest now, right? So import OS. We'll also import PyTube. Run the cell. Next, what we want to do is come and basically save this URL here, right? So we'll say our URL is equal to, this is our URL, right? So, and the way you download from PyTube is you say pytube.youtube and you give it the URL, right? So that becomes, this clearly is not right. Yeah, so this is how you instantiate the PyTube instance. And now using PyTube, we'll download the video. The way to download is you say yt.streams.filter. You will say progressive is true. File extension. I'm just first loading whatever Google GitHub Collab was giving me, and then we'll go through it. So yt.streams.filter, progressive is true. Seems okay. File extension is MP4. Order by resolution, yes. So we are going to get the highest resolution in the descending order first, and we are then going to download it. We are I'm not specifying any path here, so dot download, it basically means if you don't specify any path, it is going to just download in the current working directory, right? So that's my objective. So yeah, so let's just do that. Once this is done, we should see a file come up here, right? And the default file name for these files is the name of the video.mp4. It's still downloading. I think it must be a little largish file, so still downloading. I think it's all done now. And what you can now do is this YT object that we created here, I can use that to print a lot of details, like things like, hey, what was the title of the video, right? So yt.title. I can print what is the how many views does this video have, right? So I can say yt.views. I can even print the description of the video, and it will be yt.description. So all of these calls are available. Then we can even print the length. I can say print length yt.length, right? So, and this is in seconds, so I can just say these many seconds, right? So let's just run this. This is the video we just so the URL that we got, this URL corresponds to this video, which title is this much. These many views have happened. This is the description, and you know, this is the description, and the length is 1573 seconds. If you convert that to minutes, you will get roughly 28 minutes, right? So 26, 27 minutes, something like that. Right, so this is it. Now what we'll do is, I don't want this MP4 to be an MP4, and you will come to know when we do more things. What I'll do is, I'll just rename this MP4 to a file without an extension. So rename the MP4 to the title of the video without a file extension, right? So I'm going to basically just say rename os.rename yt.title plus mp4 to yt.title, right? This yt.title is basically the name of the file, right? So if you see here, this was the title of the video, .mp4 got added, and that's basically the name of the file. I'm just renaming it back to without an extension, and if you see now, the extension is gone, right? So we don't have the mp4 extension anymore. And the reason I did that is because now this becomes my raw file for doing all the processing. Now if I want to convert this, extract audio and save that as a .wav, I don't want the file name to be introducing GPT-4o.mp4.wav. I want it to be introducing GPT-4o.wav, right? So that's the reason I just removed the file extension. It's perfectly all right to skip this step, and it'll still be fine. It's just be a little it won't read that well. That's the only thing. So now that we have the video, as part of the next step, what we need to do is we have to, from the video, extract the audio. So like, let's just build build that code. Uh, Extract audio from the video. So we'll create a method and we'll call this method extract audio. So I'll say def extract underscore audio. Extract audio. Let's just see what GitHub Copilot is giving. It says audio is equal to video dot streams. Okay, so pytube also has a way by which you can just say only audio is true when we were filtering, and you can get the audio. I'm not using this method. I am basically using the MP4. Let's assume you already have an MP4. You are not even downloading. You got the MP4 from somewhere. Now we'll use FFmpeg to actually download. So what GitHub Copilot was suggesting was more of a pytube method. I'm not using that. Extracted audio is equal to, and we'll give this file a name. I'm going to say audio hyphen input underscore file dot WAV. Okay, so, and we can define here that, you know, this is my video, and we can even say input underscore file, right? So I can even define what input file is. This becomes this will be the file with which file name which I'll use to save the file when I am done with extracting the audio. Next we'll say stream is equal to, at this point I'll invoke FFmpeg and I'll say input is my input file, and we'll similarly define our output. We'll say stream is equal to FFmpeg dot output stream and extracted audio. So this becomes where it should write. I think I have not imported YT FFmpeg, and that's why I'm getting that error. So maybe I should first do some imports here. So yeah, so let's just do some imports here itself. I'll import time, I'll import math, I'll import FFmpeg. Some of these libraries I'll use once we have to also do pre-processing. So I've just imported them now. The FFmpeg error is gone. Now once I have done this, I'll say FFmpeg.run stream, and I'll say overwrite output is equal to true. And we'll return the extracted audio, right? So we'll return this file. I'll run the cell. Now we'll come to the point where we'll say audio, we'll basically call this method. We'll say audio extract is equal to extract audio YT and YT.title. Yeah, so we actually don't need to give the video. Sorry, I think I mistook it because this was a GitHub Copilot completion. Sorry, GitHub Copilot completion, and that was not right. So YT.title is my input. This becomes my input file. Let's just run it. If this goes well, within this file thing, you will see a WAV file also coming up, right? So we'll run this now. Okay, something is wrong. So I'm missing one required positional argument. I think I did not run the cell. Yeah, I'll run the cell again. And let's see if, yeah, so I got the WAV file. With that, we also got a lot of message from FFmpeg. So whenever you will run Python FFmpeg, you will see a lot of messages come up on the console. It will tell you about metadata about the video, when was it created, what type of file it is, and all of that, what the output name of the file is. Yeah, so we are at that point where our WAV file is also created. So we have the audio file. Now the audio has to be sent to OpenAI Whisper. So we are at that point where we'll now have to send this audio to Whisper. So yeah, so let's code that part now. So now let's build the transcribe function, and the way we'll do it is that, you know, we'll define a function called transcribe, which will take in an audio, and it should return to us the language of the audio. So we'll send the audio. We'll ask OpenAI Whisper model to also tell us the language, and give us the segments, right? So if you now go back to the faster Whisper, you will see that, as part of the implementation, you get some segments and you get some info, right? And it also says that segments here is a generator, so the transcription only starts when you iterate over it, right? So this can be run to completion by gathering segments in a list or a for loop, right? So I just wanted to quickly help you also understand how to read some of these documentations. A lot of users, a lot of developers generally know that there are packages, but what they don't really understand is how to use those packages. So the quickest way is sometimes just read through the code. ChatGPT is a great tool. You can just, if you are not able to understand, copy this entire thing, send it to ChatGPT, ask it, hey, what does all of this mean? That can help you learn a lot. So we are going to return the language and the segments. We're going to define the language and segments now. But our method is going to take the audio and we'll make use of, now is the point where we'll start using the Whisper model from faster Whisper, right? So from faster underscore Whisper, import Whisper model, right? So so this is what we'll make use of. We'll say once we are in this function, we'll say our model is Whisper model, and we are going to make use of the small model in my case right now. Again, go back to the documentation, and you can pick the model sizes, whatever size you wish to have. You can pick the size of the model. You have in this documentation somewhere it was mentioned, the sizes are mentioned, yeah. So there's a small model, there is a large v2 model, so you can basically find the model that you want. I'm going to make use of the small model here. In their examples they have made use of the large v3 model, right? So I'm going to make use of the small model, right? OpenAI documentation has names of all the models that are available. We are going to make use of the small model here. So, and the reason I'm making use of the small model is just for this demo purpose, because I'm not doing it on Colab where I have access to a GPU. This I'm doing it on my MacBook, and therefore I'm using the small model, right? Otherwise, I would have used the. If you are doing it on Colab and if you have access to GPUs, feel free to do like a bigger model, right? So then we'll call model.transcribe. We'll send it the audio. Our language, if you remember, even here it was sending some info. Segments and info is what the model.transcribe gives back. Within info is where you get the language, and language is basically nothing but info 0, right? So info 0, which is basically the first element in that list, will give you the language, right? So so let's also quickly just print the transcription language, and we'll say language. This becomes our language here, and this is where we'll print the language. Next, if you remember, till now the transcribe has not happened. That's what this documentation told us when we went here, that segments is a generator. So we need to iterate over it. So if you have any generator in Python, you have to iterate over it. So we'll iterate over it by calling list, like it mentioned. So we'll say segments is equal to list of segments, right? This is where the transcribe happens. Okay, so this is where the transcribe happens. Next, what we'll do is for segment in segments, we are just looping over the segments. Why is it giving me an error from? Oh, sorry. For segment in segments, we are now going to loop over each segment that the model has given us, and we just want to print the segment, right? So, and I want to print basically the time, right? So I want to print the time, and that's what start and the end time of that of this segment is what I want to print, because our final goal is to basically take these transcripts and convert them into what we call a subtitle, right? So for that we will need these timestamps, right? So that's what we'll need.
and segment 0 is basically nothing but segment dot, we'll say segment dot start, segment dot end, and whatever is the text of the segment that comes here in segment 2, that basically is the text of the segment, right? So what have we done? We have said print percentage 2.2 fs, 2.2 fs percent s, and we are then transposing these three values. These are basically segment start, segment end, segment text. These become our three values. We are just going to print these three values, and we are then going to return segment, right? So we are going to return, so the return is actually already coded, right? So yeah, so return is already coded. So this is our transcribe method. We took the audio, we defined the model, which is the Whisper model small, then we called the transcribe on the model, we got the language as part of the info. The transcription language is our info 0, which is the language. Then we iterated over this segments, and then we went through each segment and printed out the time and the text, right? So that's what we have done. Next step is to now do a time on this. We'll just time this method, this cell, and we'll say language comma segments is transcribe audio extract, right? So now we are going to call this method. So till now we only declared it. Now let's just call this method. This is going to take a while, so I'll pause the video and I'll come back once the call is finished, right? So let it run, and it's giving me some error or some warning saying, hey, you are using float 16, but the model weights have been automatically converted to use float 32. So it depends on what kind of a system you are using. It has already told me that my transcription language is EN, and we'll just let it run for a while now. So now the model is done with the transcription. We have, you can see, this is what we printed. We printed the start time, we printed the end time, and printed the text, and we have that. So now we have this ready with us. The transcript is there. We have it stored in the language and segments. Now, but one thing that you will also notice is that because we are using the small model, it's really good, but it still is not like 100% accurate. So ChatGPT is like, ChatGPT, and there are few other places where I was just noticing, not able to find right now, but there are like some minor errors, like, but because I use the small model, small is relatively faster but less accurate. But if you go to, let's say, the large models, and these are the available models within the faster Whisper. If you look at them, if I go to large V3, it will be a slower model, but it will be a very accurate model, right? So if I go to, and right now I'm using the small model, right? So medium, large, V1, V2, V3, the higher you go, the models will become slower, but they will get more and more accurate, right? So yeah, you can try. If you have access to a GPU, you should definitely try this, right? So with this, now our we are at this point where our transcripts are ready, and what we now need to do is, we are at this point now, the transcripts are ready, and we now need to get into some pre-processing. And what we need to pre-process is basically the time, right? Because this time is going to get read by the player. So we'll just do some pre-processing here now. So there are many subtitle formats available. We are going to make use of a format called the SubRip SRT format. So this is our format, and the key things when you are building this is that you need three things here. So you need a subtitle index, which is basically a number, right? So it could be like a 0, 1, 2 types. So it indicates, it's a sequential number that indicates what is the order of the subtitle in the file, right? So next, what you need is the time code. This time code basically has start and end markers for the, like what we generated till now, and it has to be in HH, MM, SS comma SSS format. This is the format in which your time has to appear. All your start time, end time, the time codes have to appear like this. And next you need basically the text, right? You know, the subtitle text. That's what you will need. So these are the three things. So this is the pre-processing that we need to do. Our pre-processing needs to result in an output which will be something like this, right? So that's what I mean by the pre-processing step here. So let's write that method now. So we'll build a method and we'll call it format time method. Def format time for subrip SRT, or for SRT, let's just say, and it'll take seconds. And what we are now saying is, let me just add some comment here. We are saying this method, this is a helper function that takes time in seconds and converts it into this format, right? So it into this format format for the SRT subtitle files. Okay. So let's see if now I gave some hint to GitHub Copilot. Let's see if it is able to give me something. Okay. So seconds is equal to math.floor seconds. Sorry. I think the code was right. Seconds is math.floor in seconds. Ours is seconds divided by 3600. Okay, I would have done slightly differently, but the math.floor is already there. So seconds is a math.floor, and you are then dividing it by 360, 3600. Minutes is seconds divided by 3600. Seconds is seconds minus 3600. Okay, I am slightly feeling lost with this code, so I'll not use GitHub Copilot. What I will do is I'll just say ours is equal to math.floor seconds divided by 3600. Then we'll say seconds, we'll take a percentage equal to 3600. Next we'll say minutes is equal to math.floor seconds by 60. Yeah, and then we'll say seconds is nothing but seconds percentage 60. Okay, we'll then say milliseconds is equal to round off seconds minus math.floor seconds into 1000. Yeah, that will be my milliseconds. Next, what do we need? We need seconds is nothing but math.floor seconds, and I'll say formatted time, this is my final output, is f of hours colon 02d colon minutes 02d seconds 02d milliseconds. Yeah, this looks good, and we'll finally return the formatted time. Yeah, so with this my method is ready. My method to format time for SRT is now ready, and we will now go ahead and create a method that will allow us to generate subtitle files, right? So what we'll do, we'll say def generate subtitle file, and we'll pass it. We'll need two things here. One is the language, the other is the segments. These are the language and segments from our transcripts that came out right earlier, these things. So we'll pass the language and the segments, and then we'll say we'll have an output file. We'll say subtitle file is I'll just call the name as sub input underscore file dot language dot srt. This becomes my output file for the subtitle, uh, and then what we'll do So now we have the subtitle file. We'll say text is empty. Sometimes these auto completions can be irritating. Next, what we'll do is we'll loop through for segment in enumerate segments. We are going to loop through the segments, and autocomplete is giving me some text. Let me just see, or maybe leave this. I'll just start writing code on my own. We'll say segment start is equal to format time. This is there. Now we'll start calling the format time, and we'll pass it the segment start time. This is the segment start time that came as part of segments. So within the segment, we are calling segment start time format time for SRT. Yeah, format time for SRT, and we will pass it segment dot start. Same way, we'll get for segment dot end. We'll get segment underscore end format time for SRT. Next, now the times are available. We'll just say text plus equal to f string, and we are going to say we need these three things now, right? So we need the index, we need the time code, and we need the text. So we are going to say first thing is str of index plus 1 and a new line. Next we'll say text plus equal to segment start to segment end. So, and third is where we'll give the text, right? So segment dot text. Next we'll just yeah, we can do two empty strings and we should be good. Two empty line breaks. Yeah. Next, f is equal to open subtitle underscore file comma w, f dot write text, f dot close. We are writing to the file now, right? So, and then we'll say return subtitle underscore file, right? So we just wrote a method that will generate subtitle file for us. I think I should also have a language input underscore file here. um, yeah, so this method will take an input file, it will take a language, and will take segments. Now what we'll do is we'll call the subtitle generation. We'll just say subtitle underscore file is equal to generate subtitle file. That's the name of the method. Yeah, and we are going to pass it yt.title. We'll pass it the language, and we'll pass it the segments. Yeah, so language and segments are there. Why is it not recognizing language and segments? Yeah, it did. So, okay, so we have the subtitle file. Let's just see if it got written. Yeah, so we can see a subtitle file has got written str index plus 1. Something is wrong with our code then. Okay. Yeah, so this should have been a variable, which instead of that we just printed it uh, as a literal string, right? So we'll just redo the file, call subtitle file again. And now we'll see, we are seeing the index numbers as 1, 2, and proper start, end, and the text. This our SRT file in English is now ready, right? So the next step is now where we'll basically take this SRT file and we'll burn this SRT file using FFmpeg onto the video itself, right? So that's the last step. We there's one step missing in this visual, which is post the pre-processing we generate the SRT file and then we get to the FFmpeg, right? So we are at that point where our SRT is now ready. We'll now write one more method and we'll be done. This method will invoke FFmpeg and the SRT file we have created to embed that text on the video. Yeah, so let's write this method. We'll call it def add subtitle to video, and it will basically take a few things. First, it will take whether the file, what is the subtitle file. Then it will take subtitle language, and what we'll do is we'll say we'll first define an input stream, FFMPEG input stream. So we'll say FFMPEG.input, and this is our input file. It's yt.title, but it's better to have input underscore file, and let's have this input underscore file here. So it will take an input file that will be the FFmpeg input stream. Then we have a stream for the subtitle, and we'll call it subtitle input stream. This will be our FFmpeg.input subtitle file. Next, we'll define an output video. This is the name of the file that we are defining here. So output hyphen input file hyphen subtitle language. Yeah, seems good, right? So our final output file will be called output dash whatever was the input file name dash whatever is the language of the subtitle dot mp4. That's our final file. That will be the name of our file. Then we'll say subtitle track title is equal to subtitle underscore file dot replace. We are replacing dot srt from the title, and we'll finally say stream is equal to ffmpeg dot output. We'll call the video input stream, and we'll call the output video. Next we'll say vf is equal to f subtitles is equal to subtitle underscore file. Yeah, so this will basically and next we'll say ffmpeg run. So this is our method. This method will add the subtitles to the video. We first define a video input stream, then we define a subtitle input stream. Next we define what the output video file's name is. Then we tell the method what the subtitle track title is. Next we blend all of it into the stream, and we run this ffmpeg with that stream, right? So yeah, so this is the method. Next, all we need to do is just call this method, right? So we'll call this method with add subtitle to video. It will need an input file which is yt.title subtitle file, and it will need language, right? So I don't know why for language every time it is saying it's not defined, whereas language is defined, right? So if we just do language and run this, I get en. I don't know why it's saying, maybe some issue with pylans here, right? So yeah, so let's forget that for a minute. This is the final call. We'll just run this call. Did we add? No. So let's see. Okay, there is an output file getting generated. It's an mp4 file that is getting generated now. It will take whatever time it takes, maybe a little while. And you can see FFmpeg is outputting a lot of metadata information. It's telling you the name of the encoder. It's telling you how many frames have got written, how much time it has already taken, and all of that, or how much time. It's in seconds. I feel 6 seconds, 7 seconds. I don't know. Maybe it's not seconds, right? So what is the bit rate? I hope it's not the time it will need, right? So yeah. So let's let it run, and then we'll come back to it. So okay, now that the code has run, let's just quickly look at the output file. This is the output that got generated. Let's just run this and see. Yeah, so you can see that the subtitles are showing up. They have been hard burnt on the video, so it's part of the video now. And yeah, as you can see now, the subtitles are part of the video, right? So so this was it, guys. I hope you learned something new and interesting. There is also a way where if you don't want to hard code the videos, hard code the subtitles on this, you just need to change this method, this line a little bit, and I'll leave that as an exercise for you. Figure out if you know. If you want to know, ask me in comments and I'll be happy to answer. But that's one small change. If you don't want the subtitles to be hard burnt on the video, right? So hard embedded on the video, right? So So today, this is what we learned. We took a video, we extracted the audio from it, then we sent it to Whisper for getting the transcripts. Once the transcripts came, we pre-processed it for time information. Then from that, we generated our SRT file. That SRT file was then used to embed the text on the video, right, using FFmpeg. Right. So this is the entire flow that we have done today. I hope you learned something new. I'm also going to commit this on GitHub, and will be part of the code will be available on GitHub for you to have a look at. Thank you so much. Have a good time.